Welcome everybody. Today we're going to continue working on our reusable TypeScript library that we're building for Connect 4. So previously, we worked on adding the initial logic for our game initialization, and we added the ability to go ahead and reset the game state. In this video today, we're going to go ahead and take a look at starting to add the logic for allowing players to place a game piece in a column in our Connect 4 board. So if you missed the previous videos, there'll be a link on the screen and in the description below. There'll also be a link to the code for where we're at today. Previously, when we planned out our class, we created a method called makeMove that will be used for allowing a player to place a game piece into a single column, and we left it to do in the code that belongs here. So before we jump in, let's review what we want this method to actually do. So for this method, we will want to allow the player to pass in the index of the column that they would like to drop their game piece into, and we will want to return the column and row where that piece lands on our game board. By adding this return value, it will allow us to easily show in our game where a new game piece was added to the board state without having to loop through all of our pieces. When a user provides a column index, we will want to do the following. First, we'll want to validate that the provided index is within the range of the columns for our board. So any number from 0 to 6, since we have 7 columns and the index starts at 0. We'll also want to validate that the game's not actually over, so players shouldn't be placing game pieces if we're done. And we'll also want to validate that our column's not already full. So once we've filled up a column, you can't place any more tokens, game pieces. We need to actually place into another column. After we validate that the move is valid, we will need to find the first empty row so we know where the game piece will land when the player drops the piece into that column. Once we know that row, we can update the internal board state to either have a 1 or a 2 depending on the current player's turn. After we update the board state, we'll finally want to check that if the game is over by seeing if the board is either full or if a player has gotten a Connect 4. Finally, we will want to update the current player's turn if the game's not over and return the column and row from when the pieces landed. So now that we have a high-level overview of the game logic that we want in this method, we're going to start adding our code. So the first thing we're going to do is validate a player's move. When we go to validate a player's move, if the move is invalid, we're going to go ahead and throw an error with a custom message. And in order to track these error messages, we're going to create a new enum called connect4error. So to do this, let's go to the top of our code, and we're going to add in a new enum. So we're just going to call our enum connect4error. And we're going to have 3 different types of errors. Either one will be an invalid move, invalid column, or if the game is over, so it's an invalid move. We'll do invalid move, invalid column, and then invalid move, game is over. And so for our messages, we'll do column is already filled. Please provide a different column. We'll do invalid column specified, and then please provide a valid column number. Then we'll do game has already ended, please reset the game. So then next in our makeMove method, we're going to check to make sure our column is within the number of columns in our game. So let's go ahead and get rid of our to-do. If our column is less than 0, or our column is greater than our number of columns, then we're going to throw one of our errors. We'll do throw new error, and we'll do our connect4error. We'll do invalid column. Then we're going to check if the game's over. So if this is game over, we'll throw another error. All right, and then what we need to do is just make sure our column's not full. So what we're going to do is we're going to do if this.board, do our 0 index for our first row, and we'll do the column that was provided. Doesn't equal 0, we'll throw another error. So what we're doing here is we're grabbing that top row of our board, and if that top space is already filled, then we know our column's filled, since we fill it from bottom to top, and then we'll go ahead and throw an error if it is filled. All right, so the next, for our return value, we mentioned that we want to return the column and row of the space of where our token landed. So what we're going to do is we're going to create a new type, and we're going to call this coordinate, and this will have our column and row. So at the top of our file, we're going to go ahead and just add a new type. Do export type, do coordinate, and we're going to set this with two properties. We'll have column, this will be a number. We'll have row, which will also be a number. So then what we're going to do is we're going to update the return value on our make move method to, instead of be void, we're going to return a coordinate. Then we're just going to go ahead and return our object for our column. We'll pass in the column that was provided. Just do our shorthand. For our row, I'm just going to set that to 0 for now. So now we need to actually determine the row of where the game piece is going to land. So to do that, we're going to start at the bottom of our board and work our way up. And if we find a row where the value does not have a game piece, that's where we'll insert our new game piece. So let's go ahead and create a new variable. We're just going to call this row. We're going to set it equal to 0. And what we'll actually do is we're going to update our return type to actually use row. Then we're going to go ahead and create our for loop. So we'll do for let I equal the number of rows minus 1. Do I is greater than or equal to 0. Then we'll do I minus equals 1. And we'll have our for loop. So what we're doing here is we're basically taking the total number of our rows and getting a value, and now we're decrementing that value, so that way we're iterating through our array backwards. So then what we'll want to do is we're going to want to check that space. So we're going to do if this board I, so our row that we're iterating through, and the column that was provided, if it's equal to 0, then we know that this will be the row that we want. So we're going to do row will be equal to I, and we're going to go ahead and break out of our for loop so we stop iterating. So next, now that we've determined our row, we actually need to insert the value of the player into that board value, so that way we know which game piece is there. So we're just going to check to see whose turn it is. So we'll do if this player's turn is equal to player dot 1. Then we'll want to set that value to 1. So I'm just going to copy this line here, and we'll assign it the value of 1. And if it's not the first player's turn, then we know it's the second player's turn. So we're just going to set it equal to 2. All right, so now that we've updated our board state, what we'll actually want to do is go ahead and change the player's turn. So I'm just going to copy this block here, right above our return statement, paste that here, and instead of doing this board, we're just going to do this player's turn be equal to player dot 2. Copy this line, place this down here, and we'll set it equal to player 1. All right, so the last thing we want to do is we need to check if the game is over. So what we're going to do is we're just going to add a to-do above this check here. So we're going to do check if the game is finished. And so what we want to do here, this is where we're actually going to check our board state to see if the board is filled or if someone got a connect 4. And this would update the game over value if it is set. So then what we'd want to do in this method here is we're just going to see if the game is over, then we're going to go ahead and return our coordinate before we update the player's turn. Because the game is over, we shouldn't switch to the next player's turn for that state. So what we'll do is we'll do if this is game over, we're going to go ahead and return the column and our row. Let's go ahead and wrap that. All right, so next what we actually want to do is we're going to test our changes by making sure that when we call the make move method, it updates our board state. So to do that, we'll be adding some additional tests to our Connect4 test file. All right, so if we go ahead and go into our test folder and open our Connect4 test file, this will add our test. And so for our recent changes, we're going to want to test the following functionality. So when a player makes a move, the method should return the column and row of the values as an object where the game piece was placed on our board. When it's the first player's turn, the board state should have 1 in the column and the row of where that piece was added. If it's the second player's turn, it should have a 2. If we provide an invalid column, we should get an error. If a column's already filled, we should also get an error. So to add these tests, what we're going to do is I'm just going to copy this function here. So our setup reset game test. We're going to go ahead and update the name of our function. So we're going to do setup place game piece test. Come to the bottom of our file. We'll go ahead and invoke our function. Then what we're going to do is update the name of our suite. So we're going to do connect for instead of reset game. We're going to do players input suite. And for our suite name, we'll do connect for players place game pieces. Then we'll go ahead and update our before each to go ahead and create our connect for instance. I can get rid of this logic here. So then what we're going to do is create our first test. So I'm going to update this here. We're going to copy this real quick. Paste that here. So add a few lines to space this out. So for our test name, what we're going to do first is make sure we get the return value for our coordinate. We're going to do should return the coordinate of the cell where the game piece was landed. Piece was placed. So we're going to go ahead and get rid of this. We'll do const. We're going to do make move response. We'll set this equal to our connect for instance. We'll do make move. And we'll do 4 for our column index. So now we just want to make sure that this response matches what we want it to be. So we're going to use assert. We'll do equal. And we're going to do the make move response. And we're going to compare this to an object. So we should have column 4 because that's what we provided. And it should be in the bottommost row because there's nothing in our board state. All right, so next we're going to add a test to make sure that when the first player places a game piece, the game state reflects that. So it's the next player's turn, so it should be players 2. The game shouldn't be over. And in the board state, we should have a 1 in our value. So I'm going to copy this block here. Paste that here. So we're going to do make move. We're going to go ahead and do 0. We're not going to worry about our response because we're actually going to check our board state. So we'll get rid of this here. And so for our test name, what we're going to do, we'll do should allow first player to place a game piece and update the game state. So now we're going to want to check some things on our actual game instance. So we're going to want to check the game over state. So we'll go ahead and copy those lines, place that here. We should check to make sure that there's actually no winner for our game. We'll go ahead, let's just get rid of this one here. And we're going to check the player's turn. And so for our player's turn, it should now be player 2. And now we actually will just want to check our board state. So what I'm going to do is just make a new variable and call this board. I'm going to set it equal to an array. And this is going to be an array of arrays. So it's going to be 7 zeros. Then what I'm going to do is I'm going to copy this. So this will represent our first row, second row, third row, fourth, fifth, and our final row. And we should have a 1 here. Then what we're going to do is make sure that this board is equal to our board state. So we're going to do assert equal. We'll go ahead and do board, connect 4, and we're going to do our board. Then I'm just going to change this to board state. Place that there. And then let's go ahead and get rid of these other tests now that we've copied what we needed for them. And then finally, we just need to go ahead and run our test suite. So go ahead and save. All right, so what I'm gonna do is I'm gonna go ahead and open up my terminal. I'm gonna go ahead and run yarn test. You can also run npm run test, and this should run our test framework. And so we should see that our tests are now passing for our new test suite. All right, so now that we have our main test done, I'm just gonna go ahead and copy this, and this will be our boilerplate for the remainder of these tests here. So we want to check the second player now. So we should allow second player to place a game piece. So what we're going to do is we're going to place another game piece. We're just going to copy this here. And then what this should do is update our board state, where we should have first the first player, then the second player. We should be back on player 1. So then we're going to check that we throw an error if we provide an invalid column. So we're going to go ahead and just update our test name. We should throw an error if an invalid column is provided, and not modify the game state. So what we just want to make sure is if we do provide that invalid column, nothing should actually change. So when we want to go ahead and test for an error with UVU, we're going to use the assert library. And what we're going to do is we're going to call throws. And what this expects is a function that when it's invoked, it's going to actually throw an error, and then we can assert what that error message is. So this function that we provide has to throw an error, and if it does not, this will make the test suite fail. So as an example, if I just place our connect for make move, and I leave this as 0, and then I'm going to go ahead and provide a error message that we expect. So we're going to do invalid column specified. And I remove this here. If we go ahead and save and run our test suite, we should see that it fails because this should not throw an error. So yeah, if we take a look at our error message, we'll see the expected function to throw, and that's where we fail because this is an invalid move. Where if we change this to, let's say, -1, so that is an invalid column, if we rerun our test, we'll see the test fails, but now it's a different error, and it's because our board state is not updated. We expect there to be a 1 here, but in reality, it should all be 0s. So if we fix that, if we rerun our test one more time, we should now see it's passing because we didn't actually modify the state of our game. So one thing to note is when we use the assert throws method here, for our message that we provide, we can either provide a string or we can provide a regex pattern that'll be used to match against the actual error message. So that's what we're doing here. We don't have to provide that whole error message. We're just using regex to check for this part of the string. All right, so next what we're going to do is we're going to check to make sure if a column is already filled. We should get an error if we try to place one more token there. So I'm just going to copy this block here. We'll paste it. And we're going to go ahead, change our test message to should throw an error if a column is already filled and not modify the game state. So we're going to leave this here, but we're going to change this to 0. And then what we need to do is actually fill up our column. So I'm going to call our make move 6 times. So this should now fill up our column. And if we take a look at our board state, let's just update that. So we should have first player, second player, first player, second player, first player, second player. And then it should now be the first player's turn because the second player placed the last piece. But our error message will be a little bit different. It's going to be column is already filled. So if we go ahead and save, we'll try running our test one more time, and we shall see that everything passes. Perfect. So now that we have the logic in place for placing our game tokens on the board, the last functionality that we'll want to add is we need to check if the game is actually over. So in the game of Connect 4, we know the game is over if one of the two things happens. Either the board is completely filled, or B, a player gets Connect 4 by getting 4 game pieces in a row, column, or diagonally. So for now, we're not going to do a deep dive into checking if a player has actually won by getting Connect 4. And we're just going to go ahead and add a method where we'll have a to-do, and we're going to make sure that the board is not already filled. And if it is, then we'll go ahead and update the game to be over. So what we're going to do is we'll come back to our Connect4 class. We're going to create a brand new method. Let's come to the bottom of our file, and we're just going to do, we'll call this method check for game end. This is going to expect the row and the column of where the game piece was placed. We'll do row, number, column, number, and we're not going to return nothing from this method. We're only going to update is game over if the game's actually over. So we are going to add a variable. We're going to call it did player win. For now, we're going to hard code this to false. I'm just going to add a to do here. So this variable would actually be updated based on if player won by getting a Connect 4, but for now we're just going to hard code it. And now we're going to check to see if the board has any remaining spots open. So we'll do const, we'll do any open spots. And so to do this, we just need to loop through the top row in our board, and if any of those spots are open, then we know that not all of our columns are filled, since we fill from the bottom to the top. So we're just going to do this dot board. We'll grab our first row, so our first index, and we'll do sum, and we're going to do cell, and we're going to go ahead and return if our cell is equal to 0. So what we did here is we just created a new variable called any open spots, and what we did is we called the sum method on our first row array, and what this will do, it allows us to provide a function that'll be invoked, and it'll check each element in the array until a condition is met, and once that condition is satisfied, it will stop iterating through our array. Basically saying, for our array, is there any element that meets this condition? So for our condition, we just want to know if the cell value is equal to 0, and as long as one of them is equal to 0, we won't process the rest. So if a player places the first game piece token, when we call this method, basically we're going to start at the top row, and our first cell would be empty, and so we'll go ahead and exit early. So then finally what we want to do is take these two new variables. So we'll do if not any open spots. So if this returns false, we know our board is full. Or if the player did win, then we're going to update our game over state. So we'll do this dot is game over, and we're going to set this equal to true. So then the last thing we want to do is actually come back up to our make move method, and we're just going to replace our to do here by calling this method. We'll do this, check for game end, and we're going to provide our row and our column. All right, so the last thing we're going to do is we're just going to run our test suite to make sure we didn't break anything, and we'll see that all of our tests are still passing. All right, and so with that, that brings this video to an end. In our next video, we're going to start looking at adding in the logic for actually checking if a player has won the game by checking to see if they got 4 in a row, column, or a diagonal win. So thank you so much for watching. I hope you enjoy the content. As a reminder, there'll be a link in the description to the completed source code, as well as links to the other parts in this series.